Today we're going to look at section 1.7, absolute value equations and inequalities. Our objective is to be able to solve one variable absolute value equations and inequalities and to graph their solutions. So what does absolute value of x mean in words? Well, absolute value is the distance that x is away from 0 on the number line. So if we look at a number line, place 0 on it. For example, if I want x, the absolute value of x, to be equal to 9, that means I want all of the values that are a distance of 9 from 0. So if I think about it, if I want to be 9 away from 0 in either direction, that gives me two possible values. It could have been a positive 9 or negative 9. Now this is a simple case. What's going to happen is we're going to make things more complicated. We're going to add things inside. For example, x plus 1 equals 9. So what does this mean? Well, I still want to be 9 away. But if I want to be 9 away, what are my possible values of x? Well, my answer is, if this entire thing could be 9 or negative 9, that means x can be 8, because 8 plus 1 is 9. Or it could be negative 10, because negative 10 plus 1 equals 9. So it makes the problem a little bit more complicated to get the two numbers when I start adding things inside the absolute value and outside, which we will see in some problems. So how do we solve? Absolute value of 2x minus 3 equals 7. So again, remember what this means. If I look at my number line, I can be 7 away. So either positive 7, or if I go this direction, I could be all the way to negative 7. So that tells me that this value inside the absolute value could either be a positive 7 or a negative 7. So how do we solve that? Well, 2x minus 3 could be equal to negative 7, or 2x minus 3 could be equal to a positive 7, because the absolute value of negative 7 is 7, and positive 7 is also 7. So now I'm going to solve each one individually. I'm going to add 3 to both sides, get negative 4. Divide by 2 and get negative 2. Add 3 to get 10, divide by 2, and I'm going to get 5. So I have two answers. X could equal negative 2, or x could equal positive 5. And those would be my two solutions for solving the absolute value. Now all problems should have two answers, except if I wanted to be equal to 0, because if you are 0 away from 0, there's only one answer, you're at 0. But other than that, if I give you any value here, positive value, you should get two solutions. So look at the second one. Okay, this one's a little bit harder because there's numbers in front and behind my absolute value. But remember, the directions or the definitions say that the absolute value has to be equal to a value, not with all this extra stuff. So your first goal is always to isolate the absolute value. And we do that with order of operations. So I'm going to subtract 3 from both sides first. I like to make my absolute values kind of obvious and really large so I can tell and don't make it look like a 41. If I subtract 3 from both sides, I'm going to get 14. The absolute value is not alone yet, so I have to divide by 2. And I get 7. Now, just like before, I can be 7 away. What values are 7 away from 0? Well, either this value inside could be at 7, or it could be at negative 7. So I'm going to do, it could either equal negative 7, or x plus 4 could equal positive 7, because these are the two values that are 7 away from 0. They subtract 4 and get negative 11, or I'm going to subtract 4 and get positive 3. So there are my two solutions. So what does it mean for the absolute values to be greater than or equal to a number? Since we've only been dealing with equations, which are fairly simple, now we deal with an inequality. So let's look at a number line and go back to our example with x. But instead, let's make it greater than 9. Well, we know before, if this was an equal sign, that means we could be 9 away to the right or 9 away to the left of 0, which puts us at negative 9. But I don't want to be equal to that. I want to be greater than that. So that means I want to be further away than 9. Well, if I'm further away from 9, that means I'm over here, or I'm over here. Those are the values that are further away or greater away from 0 than 9. But how do I show that I can't equal 9? I use an open circle like we did with our other inequalities, because it's not equal to 9. Okay. If it was greater than or equal to 9 away, I would fill this in. Okay. If we look at this symbol, how we say it, greater, no, it's not spelled this way, but if I think of greater than, this is an OR problem, and typically our OR problems tend to go away. Not always, as we've seen in some of our examples, but they tend to go away from each other. So let's look at some of these examples. Absolute value of 3x plus 4 is greater than or equal to 8. So what that means, and again, you don't always have to graph this, but if we looked at this, we need to be greater than or equal to 8. However, it doesn't just say x. If it just said x, it would just be those parts. But now I need to come up with an x so that this value is either less than negative 8 or it's greater than positive 8. So this is an OR problem. So we're going to actually write it as two problems. Either my value, 3x plus 4, is less than or equal to negative 8, or 3x plus 4 is greater than or equal to positive 8. And that's how we get our two symbols. If you notice, greater than or equal to 8 looks the same. When I put a negative 8, my symbol flipped because I'm actually going less than. I'm going to subtract 4 from both sides and get negative 12. And then divide by 3 and get negative 4. Or, here, we have 3x is greater than or equal to 4. X is greater than or equal to 4/3. Now, this graph was just to help me set it up. If I actually want to graph my solution, I have a negative 4 and a positive 4/3. I have a closed circle at 4/3 and I shade to the right. I have a closed circle at negative 4 and I shade to the left. So this would be my ultimate solution. Let's try another one. Again, this is an OR problem, but my absolute value isn't alone, so I'm going to do a little bit of work first. First thing I'm going to do is subtract the 2 from both sides. It's going to give me a positive 3. Don't ever distribute into an absolute value. It's not the same as a parenthesis. If I have a 1/6, I can multiply both sides by positive 6, which gives me 18. Now, what again does this mean? It means that I have to be, okay, I want to be more than 18 away. So if I'm more than 18 away, I'm either this direction, or more than 18 away from 0, I'm that direction. So I know this value inside, 2x minus 1, has to be less than negative 18, or 2x minus 1 has to be greater than positive 18. So I'm going to solve each one individually. Add 1 and get negative 17. Divide by 2 and get negative 17 halves. Or add 1 to this side and get 19. Divide by 2 and get 19 halves. So I'm going to graph this solution. Put down my two values. I know I have an open circle at negative 17 halves. I'm shading to the left. Open circle at 19 halves. I shade to the right. This would be my final answer. So what does it mean for absolute value of x to be less than or equal to a number? So let's think about that. So if I have my number line with my 0, and let's go back to absolute value of x is less than 9. So I know I'd either be 9 away or negative 9 if it was equal. But I want to be less than that. I don't want to be 9 away. I want to be less than 9 away. So that would be shading everything here. And then this is also less than 9. But how do I show that I can be all the way up to 9? I use open circles. Okay. If I said less than or equal to 9, since I can actually equal the value 9, these would be filled in. Okay. Now, less than, even though it's not spelled that way, less than, you kind of elongate it, reminds you of an AND problem, and typically our AND problems are shaded in between two values, and that's one way to help you remember it. So now let's try to solve an AND problem. Absolute value of 2x minus 3 is less than 5. So let's think about what that is. That means that I have to be between 5 and negative 5, but I want to be less than that. So I want to be shaded right in between there. So how do I show this graph in an equation? Well, if I was going to write this equation, I know negative 5 would be here, positive 5 would be here, and then whatever I'm looking for has to be in the center. Well, it's not just x, it's 2x minus 3. So I'm going to add 3 to the left, the center, and the right. So if I add 3 here, I get negative 2. I have a 2x in the center. If I add 3 here, I get 8. Now I'm going to divide both sides by 2. I get a negative 1 and a 4. Now when I shade this, negative 1, positive 4, I have an open circle at 4 and negative 1, and I shade in between. And that would be my solution. Let's try one more. Again, the absolute value isn't alone, so I can't do anything until that happens. So I have the absolute value of 6x minus 2. I'm going to subtract 4 and get 28. So again, just to kind of show you what this looks like to help you set up the equation, I want to be 28 away, but I can be equal to 28 away or less. So I would be shaded in between. So now to set up my inequality, I know this is an and inequality, so I'm going to be shading in between two values, and it can be equal to them, and I'm going to put my 6x minus 2 right inside. So now to solve, I'm going to add 2 to both sides, so I get negative 26 is less than or equal to 6x, is less than or equal to 30, divide by positive 6, so negative 26 over 6, I'll reduce that in a second, and 5. This is the same as negative 13 thirds. I'm going to use that number instead. And now to graph, negative 13 thirds, positive 5. And now I know I have a closed circle at each, and I want to shade all the values in between. So the last problem we're going to deal with is writing an absolute value inequality for a temperature range. So you might think, well, why do we use inequalities? When did they come up? Well, here's an example. The recommended oven setting for cooking a pizza in a professional brick-lined oven is between 550 degrees Fahrenheit and 650 degrees Fahrenheit inclusive. We talked about this inclusive before. What that means is you can equal these values. So what that tells us is that if I have this oven, it could go between 550 degrees and 650 degrees. So I need to be somewhere in between here. So what I'm going to do to make this an inequality, now an inequality, because we have a range, less than or greater than, and then to make it an absolute value talks about being the same distance away from a center. Now we don't have 0 in this case, but we can find a value that's directly in between these, which would be 600 degrees. So now I'm going to think about moving the same distance away from 600 as if this was my 0. I want to be 50 to the right and 50 to the left. I can equal 650 because it says inclusive, and I can equal 550, and I can be anything in between. So how am I going to write this? Well, normally what we would do is we know that we have to be within 50. So this is a less than and equal to 50 problem, just like we did before, 50 to the right and 50 to the left. But if I just put an x inside, that's like if I'm at 0. But what did I do? I shifted all the way to 600. So you would think you would add 600, but we're not going to add 600 because I want to subtract 600. Because if I put the value 600 in, 600 minus 600 is 0, which means it's okay. If I put a plus sign, 600 plus 600 is 1200, and that wouldn't be in the range, but we know 600 is in the range. So we want to make sure our center value, sorry about the bell, we want to make sure that this value basically cancels out our starting center point. So now that we have that, this would be our inequality that would match up for our pizza oven.